Greetings, ladies and gentlemen. My name is Feroz. I will be your presenter for this presentation, and I'm going to give a presentation on our research project named Smart Home Advisory System based on IoT-Enabled Sensor Network. All right, without further ado, let us go through into the table of content for this presentation. Number one, we'll go through background overview. Then we'll go through a little bit on the scopes and objectives, followed by getting a view on the current landscape through the literature review. Then we'll go through our methodology that we want to present, and our number five, our results and discussion. And finally, we'll end it with a summary and followed by acknowledgement and some references. All right, so let's go through into our background overview. So to get a concept on what is a smart home monitoring ecosystem. So basically, it's a concept of a connected home whereby the user has the ability to monitor their environment, indoor environment in the background and alert them if their reading is not right. So not only to detect the current environment level, but also to give valuable feedback to the user so they can take the necessary action to make sure that their environment is suitable for what they are doing. So what enables this type of application? Number one was IoT that drives the smart home monitoring system. Number two is to leverage on existing technology that is already available. And number three, to reduce gap in adopting the technology. So why are we interested in this concept of a smart home advisory system? Of course, number one, are motivated by the most crucial part, which is the system have to be useful. So the usefulness of it is very crucial. Whatever we are tracking, we need to make sure that those parameters are meaningful to our user. So things like air quality, temperature, ambient light, humidity level, all plays a profound role in the environment the user is in. Number two is convenience of using this application. Not only it has to be easy for everyone, but it also needs to make sure that it doesn't require a long setup time, leads to complexity. And of course, the time, price, and sustainable also plays a crucial role because a lot of devices in the market currently is beyond the affordability range of many of the users, and definitely for a lot of those skeptical first-time users. And let's go through into our scopes and objective. Number one, the scope is we will develop a sensor unit that could detect external stimulus, connect the data that we have obtained to the internet, and to design an appropriate packaging to hold the devices and protect the delicate circuitry and also serve as something that is beautiful for the user to put in their living space. And of course, finally, is to present the data that we have obtained in a meaningful way to the user so that they are able to take the necessary action to rectify the issue in their environment. And our objective is to monitor temperature and humidity, monitor ambient level and monitor the dust level in the environment currently. And this data will then be displayed and feedback to the user with various suggestions on how they can correct certain parameters that might not be suitable for their current activity level. Moving on, going into the literature review, let's look at some of the concepts that we're going to go through in this project, which is number one is the smart home monitoring system itself. So what's the definition of a smart home? It's whereby various devices in the house are connected to each other, and this allows the user to monitor their environment in real time. This could then lead to automation of certain tasks and also can give certain tasks more value adding proposition to it. So the diagram on the right just some of the few application of it, but definitely not limiting. And this is all enabled by a concept called Internet of Things. So nowadays, more and more devices are being connected to the internet, and this brings about the concept of Internet of Things, whereby all devices are connected to the internet. This will not only increase the application opportunity, but it also brings down the price of trying to connect device to the internet. Of course, with having your data published to the internet, it creates a few issues, mainly focused on security and privacy, and but not limited also is compatibility, as there's more and more devices being connected to the internet, but many of these devices uses a proprietary connecting method, or maybe the data might not be easily accessible. This creates the compatibility issue. So through our studies, which devices that the user, are more likely to use in the next 5 years, a lot of the studies has highlighted that users are interested in something that they can bring value to themselves, which finally focuses on monitoring systems such as health monitors, smartwatches, connected lighting, and also connected thermostat. Because these parameters are important to make sure that the living environment the users are in are the best and optimal from their current activity. So why is IoT so popular right now? Four main reasons. It's readily available, connectivity is good, endless possibilities of application, and finally, as more and more devices are connected, affordability also drop. Affordability also increases because now it's much more easier for you to obtain such devices. And what can we expect? Of course, ease of access, smart city, home automation, V2X, and just some of the ways that we can complement our life through IoT. So, like I mentioned just now, a few parameters that are very crucial for users to track to ensure that the living environment that they are in are conducive and healthy for them. Number one, the most important, definitely for a country that is in the tropical region, which is hot and humid year long, is temperature. So why is temperature important? Because it directly ties to energy consumption. In a household, the most consumption appliances is the air conditioner. If the temperature is hot, the user are forced to use more and more of the AC. This leads to higher energy consumption for the household. And of course, number two, the reason why we on the AC and bring down the temperature is temperature directly relates to our comfort level. If you're too hot, you won't be comfortable in environment. And if it's too cold, you won't be comfortable in environment as well. And this is caused by a few factors, not only the air temperature, but also the body metabolism rate and also the airflow. Body metabolism rate might refer to the activities that is being done and how many people might be in the room. So not only air temperature, but body metabolism and airflow as well. And secondly is humidity. So humidity again ties to temperature. So in a tropical country, humidity is usually high, so this could lead to health risks due to mold growth. And sometimes, due to low humidity, you can experience dry skin as well. And of course, this also leads to comfort of the user as well. And this is primarily caused by relative humidity and the current airflow in the environment. And finally, the light intensity, which affect the general behavior of the user. Because if you want to go to sleep, primarily you want a warmer light, and sometimes if you can't get a pretty good night's sleep, it might affect your health. And this is usually caused by natural light and also various light sources. Going on, these are just some of the implementation that are available on the market. And through the literature review, we noticed a few problem statements. Number one, will the system be able to give meaningful output? Number two, the ability to decrease energy consumption. Number three, can the system be developed in a cost-effective and sustainable way? Hence, solve this problem. Number one, we would like to develop a smart home system that will let the user know the current condition of their living environment and give valuable feedback to its effectiveness. Number two, ability to give feedbacks on ways to effectively use the house resources. Number three, use reliable and cost-effective sensor to produce a low-cost system. So these are some of our applications. So it's based on the ESP8266 Wi-Fi SoC. These are our temperature, light, and also dust sensor. And for our messaging protocol, we will use MQTT due to its more low power application, enable us to save more power. This is a benefit if compared to HTTP. So we can see the benefit of the low power utilization of MQTT if compared to HTTP. And for our programming tool to ensure ease of usage, we have used Node-RED. And here we go through our methodology. So this is our hardware block diagram. We can see three distinct parts: the sensor array circuit, IoT hardware, and also IoT software. So the sensor array circuit will then be connected to the node MCU, which is our microcontroller, which will then push the data through Wi-Fi to the internet, which will then be analyzed, and also displayed on the smartphone application. And sensor array development process goes through a few steps. So breadboard, sensor calibration and testing, PCB board, and of course testing of the PCB. And this is the breadboard implementation. Also, this is for the temperature sensor. This is for the light sensor. And finally, this is for the dust sensor. And for sensor calibration, we have utilized few methods depending on the sensor type, including factory calibration, scenario testing, benchmarking, offset correction, and also scalar coefficient. And this is the PCB board development. And of course, we have packaged it through 3D printing to ensure that the device is protected and also it's a convenient connection point. And this is how we connected the internet, the device data to the internet. So IoT devices will then push the data to our IoT platform, which will then create our install the broker onto a device and subscribe to the topic, which will then be pushed to our smartphone app. And this is our flow chart. So from the main area, it can be observed that the system will be activated, and then if there's any fault, the user will be notified. And the way that the sensor works is, for example, the temperature sensor. If the temperature is not as ideal as the current user's behavior, so it will be suggested to the user to rectify the issue, and the user will be feedback on what are options that they can do. And if yes, it will be displayed. So similar with the ambient light and also the dust sensor. So this is the data as viewed from our MQTT messaging protocol being sent to Node-RED, and then we can view the data on our dashboard. And this is, of course, our results and discussion, the breadboard design, the PCB design, and finally the 3D printed design. And this is our light sensor configuration. This is our temperature sensor configuration. This is our light sensor. So there is some manipulation of the data to make sure that we got the correct unit. So there are some calculations here whereby we have displayed the result in terms of lux. Similar goes to our dust sensor whereby we have tracked the readings in terms of milligram per meter cube. And this is our monitor, serial monitor output, just to make sure that the results are correct. And then this is data is then pushed to our node rate through our MQTT broker. And then this is programmed on our node rate. So we can see that it's split into different levels and we carry out the necessary analysis through our node rate application. And here we can see a more detailed area. So we have the data capture, data manipulation, and also data presentation nodes. And this is our output as seen on our app. So we have a main summary page whereby the user have a one page view of all the important levels. And for more details, they can go to the temperature section or humidity section or light section. And here they can see the current value and also the recommended temperature range or for the current what's the ideal for the activities. Same goes with humidity and also light level. And whenever the reading is outside the suitable level, so the user will get a notification and signifying that okay, this level is not suitable. You need to carry out certain steps to improve this. And if the phone is locked, the user will also receive the notification. And this is our project cost. So in the spirit, as you mentioned, one of the main uh, reason is to produce a low cost device. So we have managed to achieve that through our project, which costs 103 ringgit 70 cents only. And to summarize the research project, at the end, we have delivered a low-cost home advisory system, which not only utilize IoT network, but also able to give the user meaningful feedback so that they can correct the environment they are in. So we have completed to create an enclosed home advisory hub with IoT connection and Android app, and also finally to present the research paper. All right, so that's all from myself. Thank you so much for tuning in on our presentation. Yeah. All right, thank you. Bye bye.